Good morning, good afternoon, and good evening to you, my dear viewer. My name is Julian Cruiser, here with NodesAren'tScary.com, and I have something very cool for you today. This is a method that is quite simple, but very powerful, and it allows us to do simulations inside of Nuke, all stock plugins. And even though the technique is simple, we can produce some very complex, and dare I say, beautiful results. So, what is the secret sauce that allows us to get away with such magical feats? Well, let's jump into Nuke and take a closer look. So the technique that we're using here is a hack. You're not supposed to be able to do this in Nuke, and that's because what we're doing is creating a feedback loop. We are taking the output of a node and then feeding it back in to itself. And if you try and do this in the node graph, it bounces right back off. You can't do it. And this is because the Nuke developers knew that if you were able to do this, you would blow up, and your computer would blow up, and your house would blow up, and like it would be terrible. Or at least that's what they want you to think, because actually the real reason is you would have too much power. There's so much stuff that we can do with this, and all we need is a workaround for this little issue here. Before we get to that, I do want to say that this video was inspired by this other video on YouTube by Texture Labs, where they create this awesome smoke simulation effect. And in this video here, I'm going to show you how to achieve a similar result in Nuke. This is an After Effects tutorial. But I don't want your main takeaway from this video to be how to make a smoke simulation in Nuke. I want you to be inspired to use the power of simulations in general for whatever creative purposes you can think of, because there's a lot of possibility here. How do we bypass that circular loop thing? Well, the answer is with a read and a write. If we write out an image sequence into a folder, demo03, and I'll make this an EXR sequence because it's uncompressed and it's quickly readable. And then we read the same image sequence back in at an offset of -1 frame. This is a feedback loop, and we're circumventing the node graph by going to the file system and making it work like that. So what we have right now is not very useful because this is just an empty image sequence that's getting graded with nothing and then passed back to itself. Nothing's ever going to happen here. And so we need an initial seed, something to start out with to grow into our final simulation. And so we can do this by using a switch node. We want to say on the first frame, I'll hit equal on this which thing here to bring this expression pop-up up, and I'll say when the frame number is equal to 1, then we're on the first input. And so you can see this is highlighted on the first input, and we move to the second frame. Now we're going to the feedback loop thing here. And while I'm at it, I do want to make sure that the frame range, this is set to, I'll do a little expression here, root.last_frame. And this is going to make sure that we're always importing the entire length of the project into this read node. But now that we've got that set, we'll get back to our seed here. On the first frame, we want to use our seed. And I'll just make a little roto here, make a circle, and then put this through our RGBA. And now we have our seed. You can see through the switch on the first frame, it's the seed. On the second frame, it's a read error. And this is going to be a problem because Nuke will not let you write with a read error present. If I go ahead and check create directories and hit render for the global length, here's what happens. Wow, it's rendering so fast. No, it's broken. That didn't render at all. So how do we get past this hurdle? Well, all we need to do for this is just hook the write node up to our roto. Make sure that we're rendering all channels, not just RGB, because we need the alpha and we need other channels in the future. And then we'll just hit render. And this should go pretty fast because we're just rendering straight roto with no changes. Now that we've got something for every frame, we're going to have no issues with read errors because there's always going to be something in here. Even though the plan is for the write to be overwriting the frame that this read is going to be reading, it'll all work out. It'll all work out. So now what? Well, I say we maybe do something a little bit more interesting than grading with no settings. Let's do a little translate. The idea with this kind of effect is to make a small change every frame that adds up over time. So just to demonstrate here, let's do a little 5-pixel translate. It just looks like this, but that's going to be happening every frame. So you'll see we just set the setting once, no keyframes, and then I'm going to reload this and hit render like this. And if we wait a minute for it to do its thing, there we go. And you can see, beautiful. It's going up all by itself. So before we get any further into this, we could jump straight to this smoke simulation right now, but there's going to be a lot of iteration in this process. I want to make a little change and then do it again and then do it again and do it again. And it turns out there's some pretty simple steps you can take to make your life a whole lot easier while you're doing this. And it involves a little bit of scripting, which is fun or scary, but this isn't scary at all. Nodes aren't scary. Scripting isn't scary. Don't even worry about it. What we're going to do is create a new read node. This is going to be reading that same sequence like this. And what we're going to do in this read node is create a custom button. And this button, what we want this button to do is refresh our read one, render the right one, and then also refresh or reload the read two. And the reason we need to reload is because sometimes Nuke will cache some of the files into memory. And if you think about it, we really need the latest file from the disk because that contains our last simulation frame and it contains very relevant data. So if we have stuff stored from, the last iteration or the last, who knows what in there, it's not gonna work. So we need to reload that every time we render. And we're gonna automate that now. So all you gotta do here is click on this little pencil, and then we're gonna grab a Python script button. And this is just 3 lines of code, almost 2.5 lines of code, you'll see. But if I hit this little button here, this is the knob settings, and we'll name our button simulate, and we'll label our button simulate, ! Because we are excited about it. And then we'll write our code. So step 1, reload our read one. So select our read one like this, read one. So we're saying convert from the name of the node to the node itself, which is maybe a weird concept, but this is how we do it. And then knob, and we will select the reload knob. And then we will execute this knob. And the execute is like pushing the button. Next, nuke.execute, because it's a little different here, write one. This is how we render a write node in Python. We just execute it like that. And then we'll just copy this first line right here, paste it down here, change this to read two. Now we're reloading this one as well. And I can close this and hit simulate. And now you can see we've got exactly the same thing that we had a second ago because we didn't change anything. So now that we've got our setup ready for doing feedback loops in Nuke, what can we do with it? Well, let's jump straight into that smoke simulation, shall we? Now I'm just going to pretty much translate over that tutorial that I mentioned at the beginning, the Texture Labs tutorial, because it's so great, but there is a lot more stuff that you can do with this setup, as we'll get into later. Anyways, what do we notice about smoke? It goes up, generally, so we will keep this transform in here, pushing it up. What else? Well, it tends to diffuse, so we're going to use an erode to sort of bump it out. And remember, we want to just make small changes, so size of 2. It'll add up over time. And then maybe blur it out a little bit so that it diffuses a little bit. What else? Well, if we just take a look at how this looks right now, you can see it's looking interesting, but it's lacking a few things. One of these is that it stays the same brightness all throughout. And smoke, as it gets more diffuse, we tend to lose density and it gets less bright. So let's take a little grade node here and we'll just grade down one little step at a time, iteratively getting darker as time goes on. Of course, we can't see it in the preview. Iteratively getting darker as time goes on. If we do this, now that's getting closer. Well, what else is missing? There's a lot of detail missing for me personally. So what I'm going to do is bring in some noise. Whenever you need something to be more realistic, the answer is always just noise. So noise texture, how do we integrate this? Well, what we could do is just stencil out some of the noise texture onto our seed here like this. And maybe we don't want to make it 100%, we'll do maybe 50. And if we do this and animate our noise a little bit, we'll do a little expression here, equal sign to bring that menu up, frame divided by 20 is going to animate our noise like this. And if we see how this is looking in the simulation, now we can really see how things are starting to get interesting. One thing that I don't like about how this looks right now is that the shape stays pretty much the same. So let's bring in some distortion, shall we? So my favorite distortion gizmo available for Nuke is X-Distort, or at least one of my favorites. And the reason that I like it is because there is some very cool direction options here. Also, it's just easy to use. You don't have to shuffle stuff into other channels like you do with iDistort. But anyways, I'll leave a link to this in the description. I highly recommend it. But what you can do is just plop in the noise like this into the distortion map. And then the direction sets whether the image will be attracted to the bright spots or to the dark spots or spin around the bright spots, which is exactly what we need for this setup here, because smoke tends to swirl around, and that's the effect that we want to achieve here. So what I'm going to do is turn down this blur map that allows us to have more detail and turn down the distortion amount to maybe 6. And we can see what this looks like just as a preview on a single frame. And let's see maybe a little bit more blur map. Yeah. Let's see what this looks like when we simulate it. I do just want to say, while this is going, the beauty of this technique is that it is using the previous rendered frame, because there are methods where you can just, if you think about this, you could achieve the same effect by stacking like 100 effects or 100 nodes on top of each other with slightly different values and everything and time offsets, but it would be insane render time because it would like go up exponentially. But this, it's just one at a time, and you can use whatever nodes you want, and it's pretty fast. But anyways, this is done. Now let's see what it looks like. Now we're getting somewhere. Check that out. That is pretty cool. So that is pretty much the smoke effect. There's some more stuff that you can do to make this interesting. Of course, you can add different noise here. You can merge two sets of noise on top of each other, adding it together, make this one bigger, adjust the seed by adding something to the offset, and maybe turning down the gain. This will make some bigger ripples in the smoke. And yeah, there it is. You can see we've already in just a short time achieved a pretty cool effect, and there's all kinds of stuff you can do to augment this. I mean, you can render multiple different layers of it at different detail levels, like large details and small details, and then composite them on top of each other, and that makes a more rich sort of result. But there's so much more that you can do with this. Like, for example, you don't have to have your seed be a roto, and you don't have to have your seed just be there for the first frame either. All I did was pull an HSV tool key on this little coaster, and I used it as an emission source, or the seed basically, for the simulation. And there's some extra tomfoolery that's going on in here to give the smoke inertia, and I might do a video on that if you guys are interested. It's interesting. There's velocity fields taking advantage of all the different channels in Nuke, but that's for another video. But you can see, like, look at how well that works. And there's even more stuff that you can do with this. The potential is unlimited. For example, you don't have to have the, you don't have to have just a black and white image. All of this is like distortion effects. You can put a color image in. Here, I vaporized myself. It was easy. And it's all using similar sort of techniques. You don't even, like, simulation, smoke simulation kind of effects are only one of the potential things. You can make fractals with this. This was a super simple setup. This is just 3 transforms in the shape of this, taking the input image and arranging it into a triangle, and then boom, you have this, which is crazy complex and beautiful, and it was super easy. And like I mentioned, I don't know if I mentioned this earlier, but you have blink script. Like, you can use blink script as the intermediate effect, and that opens up so many possibilities. Like, anything you can do in a programmed simulation, you can do inside of Nuke now. You could probably do a fluid simulation that's like physically accurate if you wanted to. Earlier today, I did a implementation of Conway's Game of Life inside of Nuke. Here's that. And it was pretty simple to do. Like, I just see a lot of possibility in this. So with all that being said, I know this is less of a step-by-step kind of tutorial, but I was really just hoping to get across this general technique that you can apply to so many different situations. If you're interested in any specific tutorials for any of the demos you're seeing here, feel free to leave a comment, and if there's enough demand, I'll make another video. If you make anything with this technique, I would love to see it, so please leave a comment or send me an email, and I'd love to check it out. Thank you very much for watching this video, and I hope you learned something from it. Even if you didn't, I hope you had a good time watching. My name is Julian Cruiser here with NodesAren'tScary.com, and I will see you in the next one.